we are going to look at multiplying and dividing rational expressions. So if I can get the multiplying down, I can do the dividing because it's very, very similar. It's just one extra step. So the first thing we need to do is factor, because you cannot just get rid of things. Like I can't get rid of b's here, or I can't get rid of this b squared and this b squared, because they are connected by addition and subtraction signs. So you can only get rid of factors. Only things that are multiplied can you get rid of. So we want to break everything down so we can take out greatest common factor and we factor the trinomials. All right, so on the top, I see b squared minus 2b minus 15. I factor that. I want numbers that multiply to be negative 15 and add to be 2. All right, so what numbers would multiply to be negative 15 and add to be negative 2? That would be negative 5, positive 3. So because the coefficient of b squared is 1, I can just straight use those factors. I do not have to do AC method or guess and check method. So b squared minus 2b minus 15 factors into b minus 5 times b plus 3. Okay. All right, on the bottom, I just have a common factor. It's not a trinomial. I don't have b squared, but I do have a greatest common factor. And I can divide both 8 and 20 by 4. So that would leave me 2b plus 5 when I divide both of those terms by 4. Okay, on the top of this fraction, I have a common factor of 2. So I'm going to factor out a 2. So remember, I'm dividing these by 2 when I factor something out. So 4 divided by 2 is 2, and there's a b with it. 10 divided by 2 is 5. On the bottom, I see I have a trinomial, and I have a square term, so I'm going to try to factor this. So I want numbers that multiply to be negative 20 and add to be 1. So 5 and 4 multiply to be 20. If my 5 is negative, I'll write it over here in case you've forgotten how to factor. So I want numbers that multiply to be negative 20 and add to be 1. Not sure. So 5 and 4, and one of them has to be negative, and I have to add to be negative 1, so I want the 5 to be negative. So I have x minus 5 and x plus 4. Okay, before I go on, I want to talk about domain issues, like what would be problems in this, and this is going to lead us into solving rational equations, so we want to go ahead and be really good at this. So what makes this function or these fractions undefined is whatever value of b makes the denominator 0. So once I get this to factors, speaking of b, I changed these to x's. I'm so sorry. Let's get those back where they're supposed to be. I'm sure you guys caught that. Okay, so whatever value of b makes the denominator 0, I'm going to kick that out. So I'm going to set each term equal to 0. Well, 4 equals 0, that's nothing. 2b plus 5 equals 0. And I want to solve for b, so I subtract 5 from both sides, divide by 2, so b can't be negative 5 over 2. All right, we have b minus 5 equals 0, so I add 5 to both sides. B can't be positive 5, and I have b plus 4 equals 0, so I subtract 4 from both sides. B can't be negative 4. All right, so those are the three values that I have to kick out. They would be domain issues. And again, they're domain issues because if I plug a 5 in right here, 5 minus 5 is 0, 0 times anything over here, which would be 9, is 0, and now I have a 0 in the bottom of a fraction. We can't have that, can we? Nope. Okay, back to our problem. I can reduce, since this is multiplication, I can really just draw this line straight across, because when I multiply straight across. So now all of those factors are on the top, I have all of these factors on the bottom. I can get rid of factors that are exactly the same. So I have a b minus 5 and a b minus 5. Those are gone. I have a 2b plus 5 and a 2b plus 5. Those are gone. Okay? I can also reduce numbers. So do you see that I have a 4 in the denominator and a 2 that are multiplied? They're outside the parentheses. So I can reduce those. I can divide this one by 2. That becomes a 1. And divide this one by 2. And that becomes a 2. These that I got rid of become 1s also. And I'm multiplying all of these together. So when I multiply 1 by things, it doesn't change anything. All right? But if everything goes away, remember you have a 1 as a placeholder up there. So on the top I have b plus 3. And on the bottom, so 1 times b plus 3 times 1 times 1 on the top. On the bottom, 2 times 1 times 1 times b plus 4. So I have 2 times b plus 4. And you can leave it like that. You do not have to multiply it out. You can just leave it in factored form. Okay, here's the cool thing about dividing. You already know how to do this. Okay, so my problem would have started out looking like this. I'm going to use the same problem. We're not going to work through it. I just want to show you. My problem would have started out b squared minus 2b minus 15 divided by 8 plus b, 8b plus 20. And then it would say divided by, so pay attention to your symbols, b squared minus b minus 20 divided by b 4b plus 10. Okay, so here's the process on this one. If it starts out as a division problem, I switch it to a multiplication problem. So the first fraction stays the same, and I multiply by the reciprocal. So I flip the second fraction over. Okay, so here's why. I'm just going to use numbers so it's not too messy. But if I have 4 divided by 5 divided by 3 divided by 7. Okay, 4 divided by 5 divided by 3 divided by 7. All right, we've done this before. I stacked it as a fraction. When I get rid of the bottom so that I don't have 4 layers of fractions, I multiply by the reciprocal. So do you see this becomes 1 on the bottom? 21 over 21 is 1. But do you see how this changes to this? The first fraction doesn't change. Change it to multiplication. Multiply by reciprocal. Okay, not only does that work with numbers, that works over here with rational expressions. So then we do the same thing. Factor the top, factor the bottom. Get rid of things we can get rid of. Okay? If you need help, come see me.